Correct? Yeah, okay, fine. So this is basically HBase architecture. Oh, sorry. Are you able to hear me? Yeah, okay. So basically HBase is following the master slave architecture. It's here master and slaves will be there. So internally it's depending upon HDFS and zookeeper. Zookeeper will be useful for coordinating purpose and HFS is useful for storing the data. So in this next picture you can see. Okay. So it's the complete overview of the HBase. So below under the below this dashed lines, this is the HDFS. This is the name nodes, all are name nodes, right? Sorry, data nodes. Along with name node is there. So whatever the data is generating and storing in HBase tables, internally it is storing into the HDFS. Hadoop only. So this is the this is a master machine. This is the one slave and this is another slave. I can say the H agent server, this H agent server. Internally, if you insert any data in a table, HBase table or retrieving any data from the table, then first the when client sends a request, that will come to the master, H master. Zookeeper will be there everywhere to coordinate the requests and other things. So master will send a request to all region servers where exactly the data is available and how it is getting. So H region servers are here. Within the H region servers, again it will store the data in memory store. Again, memory store in the form of HBase files. These are the files. Again, it will store in the form of files. So using this table, HBase tables also. While retrieving the data, it will retrieve in the form of table. Okay, this is the log is there, hlog. So when every insert, it will not store into the HDFS or it will not retrieve data from the HDFS. Internally, it will store the data here. Only the client can interact with this memstore data, not directly this one. But after some time, here that data, whatever the update data is there, it will be updated with the Hadoop data nodes with the help of DFS client. Okay. Distributed file system client is there in between HBase and HDFS. So first it will dump the data to HDFS client, then the data will be saved or updated to HDFS below. Okay. Like this, there are dot, right? Many number of region servers can be there, but only one master will be there. So if the HDFS is not there, only one master and H region servers are there, then if it is failed due to some problem, if master is down, then what will happen? Data you will not get the available, right? Availability feature. Data will not be available here. Even data is not replicating here in the HBase region servers. Suppose one table is there, some data is inserted into that particular table, which is stored in region server 2 in some mem store. Due to some problem, this region server is down, but master is working fine and other region servers are working fine. But still, you cannot get the data, right? Because of it's not replicated in the HBase. But even if you are using HDFS, whatever the particular file is there, or file or part of data, again it will store into 3 places in HDFS by default because of the replication factor is 3. Correct? So when you are storing replication factor 3, even this region server or this machine is down, but still the master is looking for data. All the region servers, if the region servers are not able to get the data, then it will try to fetch the data from HDFS. So in HDFS there are 3 different locations are available, right, with the same data. Even in HDFS 1 or 2 locations are down, 1 or 2 nodes are down, still you will get the data from one of the other location from same rack or different rack or different data center. So this is the advantage of integrating HBase with HDFS. Because of HBase it doesn't have high available feature. I should have discussed it, right? Do you remember HBase is having what are the two features? HBase is having consistency partition, CP, right? So here availability A is missing, right? So we are getting HDFS, integrating with HDFS. Availability is also coming into the HBase. Now all three are satisfied, right? But you cannot get all three with the inbuilt of the database. Any database you can take out of 200 or 300. No database can satisfy 100%. Okay, with Capture. If you take Cassandra, is having 100% availability and a partition. But here C is missing, consistency is missing. So for this, the company called DataStax is providing durable consistency. This is the one feature. Durable consistency is the feature which is provided by DataStax company. So now if you take the Cassandra from Apache, you are missing consistency. But if you take the software, Cassandra software from DataStax company, then they will provide durable consistency along with availability and partition. This is the advantage. Okay. So basically, HBase architecture will be like this, right? Master and these are the slaves. The master and the slave architecture. But if you come to the Cassandra, it's completely different. Cassandra architecture is a ring architecture. Okay. In ring architecture, if you see, the nodes are connected like this. This is the one node, this is the one node. These are the data nodes, right? These four are the data, not the slave nodes, which is connected parallelly within the architecture. But if you take, there are 5 data and 5 machines are there in Cassandra. All 5 is connected in the ring architecture. Like this. Okay. So, and this will be connected here, this will be connected here, this will be connected here. Okay. So this is one of the most popular architecture nowadays. If you use this kind of ring architecture, here there is no master machine. Here this is a master machine, right? So all the information about all slave machines will be here in the master machine, which can be called as a metadata or master. But in ring architecture, there is no master machine. Then how? Okay, because of there is no master machine, so request can be taken by any machine, and it can serve by any machine. So if it is taken, then it will check the metadata information where exactly this information is available. Yeah, right. So it will communicate with this particular machine and will get the data and send back to client. Very, very fast, right? If only one machine is there, if the load is more, then master machine will get down, get low. Suppose this machine is down, then no issue. Still ring is there, right? You can take this is the ring.
There will be no slaves in Cassandra architecture.
No slaves. All are equal machines. All are treated as a coordinator machines.
Okay.
But
So then it will be like,
yeah, all machines will have the metadata information.
then it will be high cost, right? Compared to HBase.
Is a coordinator tool, coordinator nodes. Each machine will have metadata information. So one machine can interact with another machine. Just a moment. Each machine can act as a coordinator or master machine. As a reason, it will be very fast. Suppose out of those 5 machines, 3 machines down, still ring is there. And one more thing is here also we can use the replication factor. The same data which you are storing, suppose if you store here, the same data will be stored into the other machines also. Even one machine or 2 machines down, till you will get the data from other machine. Because of the, all other machines are having the metadata, right? So suppose one machine is down immediately, it will be updated by all the machines within the metadata. So that is the reason it's very powerful and fast.
How many machines can we connect like that in a ring fashion?
You as requirement you can connect any machines.
Okay.
And you can connect it to two different rings also. Okay, you can connect it to different rings again as a cluster. Like a data is a separate one data center and that is separate one data center. Okay, so you can connect to both the things both as a ring architecture. Peer-to-peer communication. Replication. This is the difference. This is different. When you store the replication factor 3, and you store replication. This is the separate G, one geo network is this architecture. I mean, this Cassandra ring is down. Still, data is available here to the client. Got it?
Yeah.
So this is the main difference between architectural difference between HBase and Cassandra. So if you are very good at architecture level, that is more than enough need to use. Okay. And these are the differences mostly you like to know. What are the features of SQL? What are the NoSQL features? And the differences between these two. Oh, just a moment. Give me 1 minute, please. Yeah, hello. Are you able to hear me? I'm getting a message that my audio is getting disconnected. Hello, Sharon? Hello? Okay, fine. And I will send you the documents, HBase document as well as Cassandra document also. This is HBase complete document. Just you can go through this one, architecture level. So if you are very much interested to learn HBase or Cassandra, then just go to datastacks.com. They are providing complete free course. So many people doesn't know about it. So just to go to datastacks.com and datastack, just a moment. Let me check it out. Datastacks Academy, yes. In Datastacks Academy, Datastacks, self-paced, Apache, etc. Okay, just if you are able to spend 6 to 8 hours time, then easily you will get a lot of knowledge on Cassandra. So, okay. So here they will provide training. In the trainings, self-paced courses are there. If you come down here, see introduction of Apache Cassandra. If you click start course, it's a 30 minutes and it's a 6 hours course, 9 hours, along with the practicals and other things also available. Just not only total 10 hours, it's required around 20 to 25 hours. But 100% it will be added advantage while getting the jobs. Okay. DataStax Enterprise with Spark also they are providing. This is not required. Enterprise Graph is not required. Enterprise Search and these two also not required for you. Up to data modeling, just have a look. Data modeling is required. This one and Enterprise Foundations of Apache Cassandra and enterprise operations of the data model. First 4 parts are very important. Okay, and you need to spend 20 to 25 hours. Completely freeware.
Only developer part or all the admin, architect and everything?
Yeah, sorry, can you come again?
Like the course is like regarding all admin, developer and everything?
Yeah, they have given certifications in 3 levels, right? It's a basic thing for everyone, but as a developer you can learn this one, as a developer you can learn this one. But this is the enterprise level. This will be useful for admin and architect as part of if you watch this session, then you will get more knowledge on architecture level, right? Admin level. This one data modeling is also very important.
Okay.
Okay.
So this
So
everything is
based
related
on
to
your
Cassandra?
sorry.
This everything is related to Cassandra, right?
Yeah, completely Cassandra.
Okay.
Completely Cassandra. You will get. So if you go to market, you need to spend $500 to $600 to learn the same things. I'm sure about it. Very clearly they're explaining. DataStax is a company which is spending a lot of time and okay. Are you able to get now? How much clear? How it is? very clearly. Just you can go to next. You'll get complete. It's lightweight software. Even your internet is little low, then also it will run the videos. Okay. So data stacks, but for HBase we didn't have this much priority. But then go to bigdatauniversity.com. One more site is there. Just note down all these site names. Big Data University. In Big Data University, there are multiple courses are there, but not much effective. But again, it will be useful. Go to Big Data University and go to the courses. You can go to the courses list. Just first register with the Cassandra DataStax website and this website. So here you can get a lot of things. What we are looking for, HBase. Using HBase for real-time access to your big data. It's a version 2. I think version 1 also is there. Okay, HBase beginners. This is a perfect one. It's a 5 hours. This is also completely free and open source, which is provided by IBM. Okay, yeah, this is the version 1, but it's a old version. Just only thing is you need to spend the time. Yeah, this is the two things. Just you can directly use this version 2, which is a new one. The same content, but it's an advanced one. That is the old one. That's the reason they're giving version 1 and 2. Okay. So before going to interviews or market, just to spend some more time on these things. And this yarn architecture, how yarn is working, but it's you have discussed a lot of things, and MapReduce side we have spent around 5 to 6 hours on MapReduce. So the same kind of take things and the points will be here repeated here, but in Hadoop 2.x. Okay, Hadoop 1 MapReduce 1. After that again Hadoop 2 MapReduce yarn. Okay, yarn is more faster than MapReduce, and it basically it is delegating the resources and execution things to the other resources, other areas. So it is very again good point for the interview level. So I suggest you spend time on these three things. Any more doubts on MySQL, HBase, or anything? If you want to something, then yeah. Thank you, Jankiran. From Big Data University and this one, and if you want to again, if you are more interested in MongoDB, the MongoDB University also there. MongoDB.com, MongoDB University. Even yeah, you can. Yeah, I think they are providing online courses, but I guess yeah, this is also free courses only. But you need to register. They will not provide direct one. It's a they will provide every month once or every couple of months once they are providing these things. See, public training, private training, find classes near to you. We offer 3 days or 4 days courses. So, but yeah, they are providing free classroom trainings also. But it is in different countries, organizations, right? In France and most of the Paris and in right, most of the locations are in Paris. So when you are coming to big data, 100% you need to search all these websites and demos, webinars, and free trainings, just to try to attend all these things. Okay. But these are online courses, are paid one. Just check the trainings, public trainings and private trainings. Okay, so you can use this one also, MongoDB University. These are the online courses right here. First, get some knowledge on NoSQL, HBase, and Cassandra. In Big Data University, they have given all the courses. So already you have completed Hive and Pick, right? But still, you want to get some knowledge on Hive, how exactly we are using. Then again, you can go and register with the accessing Hadoop using Hive. This is the old one. Yeah, this is our session is there. So just you can open it, you can get some knowledge. Maybe after 1 month or 2 months, you may forget, right? So this website will be useful for you. Okay, there are many courses out there. Even nowadays, R is also one of the popular tools which will be useful for generating the reports, especially statistical and analytical reports. So you can go on sometime with R also, using R with database. Okay. Clear? As of now? Basically, in Hadoop 2.x, there are few changes there already which we have discussed in Hadoop 1.x in terms of HDFS. Still we have discussed the same thing. There are one machine is there which is name node. These are the data nodes, right? This is the name node. These are the data nodes. I have one more secondary node will be there. Second name node, right? So the heartbeat signal, everything you remember, right? Which we have discussed. So these are so due to some problem, suppose this is down, then HDFS will be down. We will not get anything from the Hadoop. That is the disadvantages. And here in Hadoop 2.x, how they have modified 2.x, they're coming up with the two things. One is that instead of only one name node, you can have more than one name node. Maybe it can be 2 or 3 or whatever. And again, data nodes are same. Okay. So here all data nodes will communicate with the name node. But here in the Hadoop 2.x, it will not communicate with only one name node. It will communicate with all three. When the data node is sending a heartbeat signal, that heartbeat signal will be reached with all three name nodes. Okay, here communication will happen between these three things, not directly. Again, as I told you, there is a zookeeper is there, right? Again, zookeeper is there. The zookeeper will communicate with all three machines. Again, suppose this is the main name, this is down. Immediately the zookeeper will get the updates from here. Even if the name node is not able to sending the hardware signal to name this zookeeper master, immediately will intimate to this machine or this machine to take the charge. Okay, so this internal mechanism is there. And one more update from Hadoop 1.x to 2.x. they have created some namespace concept. In the namespace concept, so if your 1,000 nodes are there in the cluster, I don't want to create all 1,000 nodes in a single category. I want to divide the data into some accounts data into one category as a one category, and some scientific data, some sales data, and some other one. But I want to use only single cluster. At that time, they have created a namespace concept like here again. I will try it here again. So this is the name node. Okay, one name node is there here. This is communicating with. These are the data nodes. But here, this data node is having 500 data nodes. This is having 500. Actually, this is data node. You can consider this the namespaces. The sales, and this is the some scientific data or engineering data. Some data is there. Okay, these are all the data nodes. So when we are storing the data, first we need to use /sales or /engineering. That means by default it will point to this category only or this category. This can be called as a namespaces concept. Okay. In HDFS level, this is the modification. This is the updates. Main updates, means small other updates also there, but these are the main updates. But in Hadoop 1.x, we'll call it as a map reduce, right? But the same thing we can call it as a yarn in Hadoop 2.x. In map reduce, what is the architecture? Here we have a job tracker is there, which is running in name node, right? The job tracker will be having interaction with all the task trackers, job tracker and task. Task tracker is nothing, will be there in data nodes, right? It will communicate with all the task trackers. Task tracker will be responsible for completing the task and sending response to job tracker. So here in MapReduce and job tracker concept will be okay up to 1,000 to 2,000 machines. When cluster is costing more than 1,000 or you can say 2,000 machines, then job tracker will get lot of load. So basically job tracker cannot handle the things more than 2,000 machines. Because if it needs to check the list of jobs and I need to assign the jobs to all the task trackers, and again takes the response from the task trackers and sending to name node to update the metadata information. Many things are there, so which will be very, very difficult here. So there is a reason they are introduced with the resource manager and the application manager. Resource manager, application manager, and task manager. This kind of things, and they're delegating the things to the different level. Just if you go to Google, you can get it. An architecture, easy you can get it. See, these all are the architectures. If you understand, when client send a request, first the resource manager is nothing but job tracker. In job tracker, the resource manager will assign a jobs to the node managers or application managers, application masters. Okay, just application once the job tracker decide particular job which requires how many tasks, then resource manager will assign all tasks to the node manager as well as app master. So the complete responsibility of that particular job is within the node manager itself. Node manager will manage the complete node. How many tasks are running? What are the different tasks are belongs to which job? Everything will be managed by node manager. But the application master will communicate with all the nodes to make sure the complete job is completed from all the tasks from all the data nodes. Okay, so instead of doing the same work by resource manager itself, they're working with the different levels, just delegating the work in a different levels. Okay. In general scenario, just take an example. One manager is there. This particular manager is having 10 employees under him. So managing with the 10 employees is not a big deal, right? But after that, the employees are increased with 100 people within a single project. Then it will be very difficult to this particular manager, right? Then simply we can have a 10 or 15 project leads or technical leads or associate managers like under this particular manager, and each one will deal with 10 people, which is very easy to manage all these 10 people as well as this manager, right? The same thing is implemented in ARM concept. Nothing new. Got it, Sharon? Yeah. So basically these are the implementations in Hadoop 2.x from 1. In HDFS level, uh, name nodes are scaled up, and again namespace is introduced here. In MapReduce level, they introduced the YARN concept. YARN concept is more faster than MapReduce in terms of execution, in terms of executing engine and other things also. Okay, any more doubts on this? Oh, this is about the concepts of Hadoop. And we have pending things are Spark. We'll start the Spark from Monday. Me or my friend take the sessions. Maybe it may take 3 to 4 hours required. Actually, Spark is not included in the Hadoop course or Hadoop software, but based on the market, just I would like to give some knowledge on Spark also. Okay. So, any more doubts as of now? Not only today's session, any doubt on previous sessions or anything about Hadoop or big data? Because of officially these are the content, these are the course we have created as of now. But still, if you have any doubts, I will take the sessions if it is required. Yeah, HBase implementation nowadays, if you take Cloudera or Hortonworks, they are implementing. But if you want to implement it in the here in Cloudera, not in Cloudera, if you want to implement this in the Ubuntu or somewhere else, again you need to download the software and set the path in Bash RC, again same. But which will be a little difficult here. Need to configure the things. And just if you go to HBase is already there here. You can go to HBase and you can choose the software. Maybe some of the versions 1.2, 1.5 is advanced, I guess. You can go and you can download the same HBase 1.1.x .gz. Not source, this one. Always download the bin.dat.gz, not SRC. SRC will have the only source files, how they have implemented. This is the file you need to download, 107 MB. Again, you can go to work folder, set the path. You can go to here, work folder, and HBase. HBase software, I guess it's not there. Yeah, HBase is there. And again, you can go to configuration file. In the configuration file, again, there is a file called HBase-site.xml. It's almost same as Hive, HDFS, like that. So here you need to specify this particular one. But if nowadays the Cloudera or Hortonworks advanced versions are by default they are providing HBase within Hadoop. Directly you can create a database and you can create a tables like that. I'll send you the HBase complete material. So if you want, you can practice with the HBase also. Okay. While starting this one, all the five services are working now. You need to start hyphen HBase.sh. Then you need to start HBase separately. In Hortonworks, in inner start by default it will start. See, starting zookeeper first bar, right? And starting master and starting region servers. If you enter JPS, you can see HCN server is there, HMaster is there, and H quorum pair is there, something else, some internal service is running. Okay, so this one we can use. Okay, yeah. So any other doubts? Charan or Rakesh? Yeah, okay, fine. Yeah, officially we are closing the sessions today, but I will send a mail to you. That time, the same link we can use. Maybe mostly time also the same one. I'll tell you when exactly we are starting. Mostly it will be our Monday evening, by Tuesday morning only, not Monday. We'll start the Spark. Okay. Charan, just please share all the videos to all others. Yeah, can you close the session, or do you have any more? Yeah, okay then. Sure. Thank you. Thank you very much for your time. Bye, all the best.
Bye, Sati.
Bye.